Okay, today we're going over our 3.1.4 review and preview. Problem 62, we're adding and subtracting the following fractions. For part A, we have 2/3 minus 5/12. Now remember that the key is to find a common denominator between 3 and 12. So what I'm going to do is I'm going to list the multiples of 3 and 12 and find the one that is common for both, the least common, so the first one that they have in common. So if I count by threes, I have 3, 6, 9, 12, 15. If I count by 12s, 12, 24, 36, 48. Well, the first thing that I notice is that 12 is my least common multiple. So that's how I know that when I rewrite my fraction, my common denominator is going to be 12. 5/12 is already out of 12. 2/3, I have to make an equivalent fraction. I can use a giant 1 to help me. So I have to figure out what goes in the giant 1. So 3 times 4 is 12. 4 over 4 equals 1. So remember, whatever goes in my giant 1 has to equal 1. So 2 times 4 is 8. So what I'm left with is 8/12 minus 5/12, which equals 3/12. Now what I do notice is that 3 does go into 12. So I can actually simplify this fraction. Okay, we've talked about reducing. So I know that 3 goes into both numbers. 3 divided by 3 is 1. 12 divided by 3 is 4. So my simplified version, or reduced fraction, is 1/4. For part B, I'm going to do the same thing. I have 5 and 12. And in this case, I'm going to start with my 12s because it's the bigger number and I know how to count by 5s. So I have 12, 24, 36, 48, 60. Well, what I know is that 60 is the only number so far that ends with a 0. And I know that 5s will go into numbers that have either a 0 or a 5 in the ones place value. So in that case, I know that 5 times 12 is 60. So 60 is going to be my least common multiple, which means that I need to rewrite both fractions. Okay, so first step, 4/5 times what will get me to a denominator out of 60? Well, 5 times 12 is 60. So to make giant 1, 4 times 12 is 48. So it's 48/60 plus 11/12 times something will get me a denominator out of 60. 12 times 5 is 60. 11 times 5 is 55. And now I add. So I have 55 plus 48. 5 plus 8 is 13. 4 plus 1 is 5 plus 5 is 10. It's 103/60. Now if I wanted to change that into a mixed number, I would have to figure out how many times does 60 go into 103. It goes in 1 time. And if I take away 60 from 103, 3 minus 0 is 3. I cannot take 6 from 0, so I have to borrow. 10 minus 6 is 4. It's 1 43/60. Either answer will work. Okay. Problem 63. I'm filling in missing numbers to make the scaling consistent. Consistent is the key word. It has to count by the same number each time. So if I have 16, Okay, I have 1, 2, 3, 4 spots. 16 divided by 4 equals 4. So what I know is that it's counting by 4. So 0, 4, 8, 12, 16, 20. Okay. For part B, I have 50 divided by 1, 2. 50 divided by 2 is 25. So that's how I know that it's counting by 25. So 0, 25, 50, 75, 100, 125, 150. In order to make sure, again, that the scaling is consistent, I have to be counting by the same number each time. Okay, so problem 64. For each of the representations below, write the portion in each of the forms listed. Remember that a 100 block now represents 100%. Okay, so for part A, I'm going to look at this block and say, okay, well, there's 10, 20, 30, 1, 2, 3, 4, 5. It's 35%. If I'm going from a percent to a decimal, I take my decimal point and I move it to the left 2 spots. I'm dividing by 100, which means that my decimal is 35 hundredths. My fraction, I have 35 out of 100 squares shaded in. My description in words. I could write 0 and 35 hundredths. I could skip the 0 and just write 35 hundredths. Or I could write 3/10 and 5 hundredths. They are all equal. Okay, so for part B, again, I'm going to count how many squares are shaded in. In this case, there's 80 of them. So my fraction is 80 out of 100, or 80 hundredths. So my description word, I could write 80 hundredths. I spelled that wrong. I could write 8/10. My decimal, if it's 80 hundredths, is 0, decimal point, and 8. Or if I'm writing 80 hundredths, I could write 0 and 8/10 and 0 hundredths. My percent, if I'm going from a decimal to a percent, I'm multiplying by 100, so my decimal point moves 2 places, which means that it's 80%. Part C, I have 1, 2, 3, 4, 5, 6, 7, 8 and a half. It's 8.5%. So my decimal, if I have 8.5, and remember, I can have all these zeros at the end. I can have an endless number. I'm not changing my number because it's after my decimal point. Okay, so to go from a percent to a decimal, I'm multiplying by 100, which means that I'm moving. We are dividing by 100 to go from a percent to a decimal. So our decimal point moves 2 spaces back, which means that my decimal is 0 and 0/10, 8 hundredths, and 5 thousandths. My fraction, because my 5 is in my thousandths place value, I can write my number 85, but I know that it's going to be thousandths, so I can have 1,000 as my denominator. My description in words, I could write 85 thousandths. I could write something similar to what we were doing in class. I could write 8 hundredths and 5 thousandths. Part D, I'm using 2% blocks, which means that my percent is going to be above 100% because all percents are fractions out of 100. Okay, so if I look at this, I have 100 plus 90 plus 1, 2, 3, 4, 5. I have 195 out of 100 blocks shaded in. So my percent, I know it's 195% because percents are fractions out of 100. Which means that my decimal then, if my percent is this, my decimal, I divide by 100, I move it 2 spaces to the left, which means that I'm left with 1 and 95 hundredths. My description in words, I could write it just like that, 1 and 95 hundredths. Moving to the next problem. Problem 65, I'm estimating the amount of gas left in this car's gas tank with a fraction. Okay. So with my gas tank, my halfway point, this is half. It's just below half. This is full, this is my 1, empty is my 0. So let's say for a minute, I separated it again in half, which means that now I have quarters. Well, it's still somewhere in between a quarter and a half. Okay, well now what if I take each quarter and I separate that in half? That's about where my marker is for it. So what I can do is say, okay, well, how many dashes do I have? I have 1, 2, 3, 4, 5, 6. Sorry, this is a 0. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 dashes, and my meter is at the third one. So my estimate is that the gas tank is about 3/8 full, or it has 3/8 left. Problem 66. Randall and Stefano work in a restaurant. Randall earned $27.50 one day, $25 the next day, and $32.50 on the third day. Stefano works fewer hours, but more days. He earned $17.50 one day, $22.50 the next day, $12.50 the third day, $15 on the fourth day, and $17 the fifth day. Who earned the most money, and by how much more? So what I have to do is I have to add all of them together. So I'm going to start with Randall. I know I'm adding them together. I'm going to use this table to help me so I don't have to rewrite it. So I start here. 0 plus 0 plus 0 is 0. 5 plus 0 plus 5 is 10. Drop my decimal point down. 5 plus 2 is 7. Plus 7 is 14. Plus 1 is 15. 1 plus 2 is 3. Plus 2 is 5. Plus 3 is 8. Randall earned $85. Okay, now moving to Stefano. Again, I'm going to use this table to help me add. 0 plus 0 plus 0 plus 0 plus 0 is 0. I have 5 plus 5 plus 5 plus 0 plus 0. So 5, 10, 15. Carry my 1. 7 plus 1 is 8. Plus 2 is 10. 11, 12. Plus 5 is 17. Plus 7 is 24. 2 plus 1 is 3. Plus 2 is 5. Plus 1, 6. Plus 1 is 7. And plus 1 more is 8. So who earned more money? Well, Randall earned 50 cents more than Stefano. As always, if you have questions, please don't hesitate to come and talk to me.